Okay, we are live. What's up, guys? This is Dem Keys, and today we're going to be doing a slightly different stream. We are taking a bit of a detour, first of all, but also I'm probably going to be speaking a little lower today for certain reasons that I'm not going to get into. But because I'm speaking lower, so I decided to try adding a gain filter onto my, well, an extra gain filter because I already have two on the mic audio source. So I decided to add on one more, and it seems to be going well so far. It seems to be, even with me speaking low, it's picking up the audio well. I'm sure it's got its pros and cons, but yeah, for now we're gonna have to just do it this way. Just for today though. Uh, Tomorrow I can turn this off and I'll be speaking at the regular volume. I kind of like this though, not speaking very loud. But yeah, okay. So, for today's stream, what I have in mind is one of my, well, how should I say that? Like my shipment arrived. I placed an order for a bunch of Wait, hold on. We are dropping frames. Let that let that problem get solved, and then we can move on. Just let the connection stabilize, and then we can continue. Oh, I didn't take into account that my if I'm talking low, then my VTuber model isn't really going to be picking up anything. But okay, yeah. Anyways, so my wait is a signal okay? Yeah, signal is fine. So my shipment arrived today, and a bunch of the stuff that I had ordered, actually almost all of the stuff that I had ordered, it arrived. I've got a bunch of modules. I've got a bunch of ICs, assorted ICs, stuff like what was it? What was it? Shift registers. And well, I got an assorted box. Oh shit! I just remembered. In that same box, the shift registers box, because it's an assorted ICs box, there were also a couple of logic gates which I can play around with. I literally just remembered about that. Yeah, dude, I should play around with that. I should try setting up some circuitry with that. I don't even need a microcontroller for that, if if I'm not mistaken. Yeah, I don't think I need a microcontroller for that. Hell yeah, dude. Okay, I can play around with that. At least that way I can test out some of those ICs and see how well they're working. But yeah, okay, so I give me a second here. I was asking Gemini for some information regarding these items that I had ordered, and then I was also having a different conversation over here, relating to BJT and MOSFET transistors that I had. I found a box of assorted transistors that I had ordered a while back, and I just needed a bit of a refresher on, well, all of those transistors, how they, what their characteristics are. What's the I was about to say what's the max voltage, but it's not the max voltage that I'm worried about. It's more their specific ways of working. To be fair, I don't know like too much about transistors to be able to like differentiate between one and the other. And well, some of these were actually built for higher power applications as well. I think we can find that out here when I'm as I'm reading this. But yeah, okay. So with the transistors, these are six of the different transistors that I found in the box. Five of them are BJTs, and one of them I thought is a MOSFET, but I'm wondering if I was mistaken because that looks like a MOSFET. All right, dude, this is unfortunate. Well, the stream cut out, and for some reason, oh, let's, yeah, disconnect protection ran out as well because OBS was having trouble reconnecting, and yeah, the stream just crashed. So, anyways, we're gonna continue reading this. So I have a couple of transistors that I was looking at, and one of them is this tip 31C, and I was under the impression that this is a MOSFET transistor, but for I think I was on words. I think I was under that impression um, because of the shape, because of like what it looks like. I had no idea that BJT transistors also look like this. Okay, it is designed for general purpose switching and linear amplification, featuring a 100-volt 3 amp rating in a TO220 package. It's not a MOSFET. It relies on base current for control, unlike the voltage-driven gate of a MOSFET. I think I have a lot to learn about transistors then. Yeah, I think I have a lot to learn about transistors because what I've learned so far is that BJTs, they tend to be current controlled, and MOSFETs tend to be voltage controlled. But other than that, I was also expecting the shapes to be different. So like the design, I always associated BJTs with a very specific shape, a specific look, and MOSFETs with a very specific look. So each time I would see, um, I don't even know how to describe what I'm talking about. But like MOSFETs, they have a certain look, which at this point I'm not really sure how true that is. So I guess I need to do more research. Which one of the future streams is going to be learning the basics of analog electronics through Gemini. So I do need to set up the prompt for that, and hopefully we'll be doing that on stream. Once I manage to look into, once I manage to set up a space where I can actually point the webcam and have the all of the electronic components and breadboard and all of that stuff displayed. Okay, so this shows Uh, okay, high voltage up to 160 volts, moderate current, IC up to 600 milliamps, HFE typically 80 to 250. These all of this data is not necessary. It's not really making sense to me because, well, I don't know too much about transistors. I think the HFE was the current that you're supposed to give to the base in order to actually quote unquote activate. I don't know what the actual terminology is, but like in order to activate the transistor and allow it to or make it allow current to flow through. I think HFE is that current. I could be wrong. Okay, applications: general purpose amplifier and switching for low level, high voltage signals, suitable for circuits where higher voltage is needed. Okay, then the one below is a PNP BJT. Characteristics: low power, VCE up to 40 volts, current up to 200 milliamps, HFE typically 100 to 300. I feel like I might be wrong about the HFE thing. Okay. Applications: general purpose amplifier and switching applications. It's complementary transistor. It's the complementary transistor to the 3904, which is the next one, and that's an NPN BJT. This is low power. Okay. It's basically the same as the other one. but one is PNP and the other is NPN. Okay, a very common general purpose amplifier for switching applications, excellent for basic logic, signal amplification, and driving small loads like LEDs. Oh, that's interesting. Okay, they mentioned that for NPN. They didn't mention that for PNP. Yeah, that's kind of interesting. Okay, so then we have this one, 2222. That's medium power, VCE up to 30 to 40 volts, ICE up ICE IC IC um, up to 800 milliamps. Okay, okay. Widely used for switching and amplification, especially for higher currents than the 3904, making it suitable for driving brighter LEDs or small relays. Okay. Then 5401. This is high voltage, moderate current. Okay. All right. And then below here we have this one. So now, as I'm learning about transistors, I'm going to need to do research about whether the higher power transistors can be used in lower power circuits, as in would they work just as well, or would there be any sort of complications or any diminishing performance or anything like that. Okay, so that's it about these transistors. I can ask questions. I can ask more questions about the transistor later on. Then I'd asked another question, which was, yeah, this was about daisy chaining. And then here it was about shift registers. So I was like, okay, let's just pretend I'm completely new to shift registers, which, I mean, technically, yes, I am completely new to shift registers. But yeah, let's just pretend I'm completely new to it and I've never done research on it. So just like teach me about shift registers. The specific one that I ordered was this one. Give me a second. This one. SN74HC595N. Okay, so this is a shift register, specifically an 8-bit serial in parallel out shift register with a storage latch and 3-state outputs. It's very common and useful. Uh, it is a very common and useful IC for microcontroller projects. Here's a breakdown of what it is, how to use it, and its applications. Okay, shift registers. Its primary function is to convert serial data, 1 bit at a time, into parallel data, multiple bits simultaneously. Then 8 bits. It can control 8 individual output pins. Okay. Serial in, you send data to it 1 bit at a time over a single data line. And parallel out, it stores these 8 bits and when told, outputs them all at once on its 8 output pins. Okay. Then storage latch. It has an internal latch that holds the 8 bits until you've shifted in. The 8 bits of data until you've shifted in. This allows you to shift in new data without immediately changing the outputs, preventing flickering or unintended intermediate states. That is useful actually. That is very useful, especially if I'm expecting, wait, Zainar, hello, hello, welcome to the stream. Today we are doing a bit of a short stream. I'm just doing some electronics research. I'm researching, well, prior to this, we were looking into some of the transistors that I have. I was just reading some of their properties. And right now I'm looking into something called a shift register, which lets you send in data on like a small number of pins and then use that to control a bigger number of pins. So in this case, it's serial in, parallel out. So through this, I'm going to continue reading what the thing is, and it's going to eventually say that. But like, this is because I've done research on this previously, so I'm able to mention it. But yeah, you're able to essentially expand your collection of Are we good? I think we are good. Okay. Uh yeah, I think we are good. Yeah, sorry about that. Um my system is just not doing well today. First of all, I started the stream late. I was supposed to start it a little bit earlier, but unfortunately I started late, and then whenever I did try to start, then started having the hardware issues. And yeah, it's been wild. We're back. Yes. Thank you for sticking around, by the way. Appreciate it. Yeah, I'm doing research on this shift register because I ordered a couple of parts off of AliExpress, and well, they arrived today. So I've been doing some research on various. Well, so okay, there's the shift register. There's also a bunch of logic gates that I got that I'm going to be playing around with after the stream, and I got a couple of modules for a variety of different things, like what category do I put? Well, okay, I don't need to categorize it. I ordered temperature sensors, humidity sensors, moisture sensors, a mic module, as I mentioned before. There's also light intensity sensors. There's a bunch of RF related stuff for various frequencies. I also bought some long range RF related stuff because apparently they use different modulation methods. Long range versus, I forgot what the other one was, what modulation method it used, but the method of modulation is what allows it to communicate over long or short distances. It's really interesting. Like once you get into RF, it's like a whole, it's like a whole other, it's a whole other world under electronics. Oh, I want to buy some stuff like that myself for like a home monitoring station. I have a Raspberry Pi and a lidar module so far. Okay. I want to get a Raspberry Pi for myself as well. One of the newer Raspberry Pis. I want to get one that has, because like in the newer ones they have PXE boot enabled by default, and in the previous ones you would have to start the thing up at least once using by connecting it. First of all, you would have to copy the, what do you call it? You would have to copy the OS onto the SD card and then put the SD card into the Raspberry Pi. Of course, power it and connect it to some kind of display, right? And then in there, you would then have to run some command to set some bit, which basically then tells the Raspberry Pi that, okay, now we have PXE boot enabled, and further from that point, you can then do PXE boot. uh, I I have one of the older ones and I want to get one of the newer ones. So I have PXE boot by default, and then I can use a bunch of different Raspberry Pis in headless mode just by like SSHing into them. And so I don't need to connect them to displays at all. I want to set up a nice little home lab for that. I'm trying to find ways to get Raspberry Pis directly from the dealer, because like the moment I try to get it from somebody else, there's a markup because they have ordered a bunch, and they had to pay for shipping and this and this and this. That's also why I don't want to buy it like locally. But yeah, I'm gonna have to see how to go about setting that up. Yeah, the SD card copy stuff was a huge pain. I did that, and I think that might still work because like I set the whole thing up myself without using one of their tools. I'm sure if like okay, back when I had done it, I decided to go with the hard route. Actually, I don't know if I purposely chose to go the hard route, but like I did like manually do a bunch of things, including stuff like using DD to copy stuff into the SD card, and eventually when I plugged the Raspberry Pi in, It didn't work directly because the Raspberry Pi apparently has a higher. I think it's because of the current. I don't remember. I believe it's because of the current. The Raspberry Pi has like a higher current requirement, and so it wouldn't work right off the bat. And even if it would have worked with whatever I was trying to power it with, well, I was trying to power it with a phone charger, and you get like these dedicated Raspberry Pi adapters. I don't have one of them. I should get one of them though. The next time I buy a Raspberry Pi, I should definitely get one of them. The voltage and current requirements are definitely weird. Yeah, yeah. I was trying to kind of get around that, but then it didn't, because like the voltage, I believe, actually, you know what? I think the voltage might also be higher than, I don't remember. Hold on, wait. Because I'd had a conversation with Gemini regarding this. Wait. Hey, remind me again why I cannot power an RPi with a phone charger. I can't remember exactly what the issue might have been, but like when Gemini explained the thing to me, then it made sense, and I was like, okay, so it's not that my Raspberry Pi had an issue with it, or that my SD card, setup process had an issue with it. The issue was the power, so it wasn't being powered well enough. Um, the most recent one is 5 volts, 5 amps. Okay, which only they use. You can use less, but it has warnings about the current draw. Yeah. Okay. So 5 amps is definitely something that you would need a much higher power charger for, because your usual phone chargers, they don't usually put out up to 5 amps. They put out like maybe 2. It can be anywhere between 1.5 to 3 amps, I think, and even 3 is a bit of a stretch. So at least, the cheaper phone chargers. I don't know about like, branded phone chargers and ones with the fast charging capability. I don't know if fast charging capability does help here at all, but like I don't have a fast charging phone charger. I have a fast charge. Holy shit. Wait, this just occurred to me. I have a power bank that has fast charging capability. But like fast charging is for phones. That's not gonna really help the Raspberry Pi situation. But my point is, because it supports fast charging, it is able to give a higher amount of current, albeit for a smaller amount of time, but it's still able to give a higher amount of current. I'm gonna have to see if that's a possibility. It's technically in the PD spec, but no one else uses it. Fast charge usually means 3 amps, which should power the Pi. I'm gonna have to see, because I have one of the older ones. It's a Raspberry Pi, I think 3 model B, I think so. It's definitely one of the older ones, but despite it being old, my charger wasn't enough to power it. Hold on. I think even Gemini is going to tell me this exact same thing. It was about the current requirement, if not also the voltage requirement. Okay. It's a classic "it works until it doesn't" situation. To be fair, you actually can power a Raspberry Pi with a phone charger in many cases, but it's generally considered a rookie mistake for a few very specific technical reasons. Here's a breakdown of why phone chargers and RPi power supplies aren't actually the same thing. Voltage sag. The undervoltage lightning bolt. Phone chargers are designed to charge batteries, not run computers. When a phone charger when a phone charges, the battery acts as a buffer. If the voltage dips slightly, the battery doesn't care. However, a Raspberry Pi is a high performance computer. If the voltage drops below about 4.63 volts, the Raspberry Pi becomes unstable. Okay, phone chargers often have loose voltage regulation. As the Pi starts working harder and drawing more current, the charger's voltage sags, leading to random reboots, SD card corruption, or the dreaded yellow lightning bolt icon on your screen. Okay, the fastest phone charging plug in my house is my standing desk. For some reason, it has the Samsung super fast charge chip in it. I should look into if I would be able to power the Raspberry Pi, because like this is an older, like the what I'm the Raspberry Pi that I have is easily more than 5 years. Actually, at this point, no, at this point it's probably close to 10 years old. How old is it? Well, okay. I got this. I'm trying to count the years because I think I got this 8 years ago. Because we are in 2026 right now. I think I believe I got this somewhere in 2017 or 2018. So it's close to a decade ago. So I don't know if it's gonna have. I don't know if actually I don't even know if Raspberry Pis now have like a that's the support for the fast charging protocol, because like whatever you're trying to charge, it should support that protocol. Otherwise, fast charging isn't really gonna happen. Yeah, I'll need to look into that. But even other than, oh, you know what else I was planning on doing? Because of the I just remembered this. Because of the current requirement, what I was planning on doing was um trying to power the Raspberry Pi using a PC power supply, because I have PC power supplies, and I know how to do that trick where you can so you just bridge two pins in the power supply's connector, and further from that point, you are able to use this power supply to power anything. So as long as you turn on the power supply, or you turn on the switch, it's going to be putting out uh, basically all of those wires can be connected to. You can power anything off of them. And the PC power supply gives you 12 volts, 5 volts, um, and I think 3.3 volts as well. It's not just the voltage, but also the current. It can put out quite a few amps. I don't remember exactly how much, but it can put out quite a few amps. I need to see how much it can put out for 5 volts, but I'm pretty sure it can put out. I'll just need to solder the connector on and then try to power the thing. Okay, the newest Raspberry Pi is 5 volts, 5 amps standard, and 5 volts, 3 amps minimum. The old ones definitely run on much less. You know what? I can try. I'll have to see if this voltage drop issue is also a thing with PC power supplies. I don't think that would be the case though, because I would imagine that for a PC power supply, you probably need stable voltage. So they probably have circuitry in there to maintain a constant voltage. So if it says 12 volts, it's a constant 12 volts. If it says 5, it's a constant 5. Because if we're talking about powering, computer parts and stuff, then you don't really want to have your voltage jumping all over the place, because that would definitely be an issue. But yeah, yeah, I need to I need to look into that. I also need to find a way to connect. I need to find something that I can safely connect this Raspberry Pi into when I'm powering the thing. I think first I'm going to power it with the power supply and make sure everything is fine, everything is stable. Dude, it would be so much simpler if I can just buy a new Raspberry Pi, and using that Raspberry Pi, I'll directly do PXE boot, because I do not want to. There are two things I'm trying to avoid here. Okay, one, I want to avoid having to connect the Raspberry Pi to a display. Two, I want to avoid having to do any memory card related stuff, any SD card related stuff. It is a huge headache for me. I just don't want to do that. Even with the tooling that they provide, I just don't want to do that. What I want to do is specifically, sorry, that's a little loud. Um, what I want to do is specifically PXE boot. And because the newer Raspberry Pis support that, so I kind of want to try with the newer Raspberry Pis. But I also want to get Raspberry Pis for cheap if I'm able to. So yeah, I need to see how to go about doing that. Are they unreasonably expensive locally? To be fair, I haven't looked. I haven't looked at all of the stores that are selling it, but I remember one of the stores that I checked out. Let me convert the thing for you and tell. Wait. Okay, and what is the price that they're selling it at? Let's see, Raspberry Pi, RPi, model. I don't know, what is it? Model 5 price. Give me a second. We are looking at Raspberry Pi 5 16 GB. No, I want to go for the lower end one, because I want to get the price of the cheapest one and then tell you how much a similar one costs for me. And this was the Raspberry Pi 3 model B. So this is 16 GB, which costs $145. Is there an 8 GB version? I think there might be. I think there might be an 8 GB version. There's also a 4 GB version, but they're not showing the price for that for some reason. They have only shown it for. Where do I see the price for that? Give me a second. Raspberry Pi 5 8 GB price. I think the one that I have is 4 GB. Hold on, there's a 1 GB Raspberry Pi 5 available, and that's $45. That's crazy. 8 GB, I believe, is $80. Okay, so I'm gonna convert this now. Let's say $80. Right. So if we are comparing the price of 8 GB, I think mine is a Raspberry Pi 3 Model B, 4 GB. The price for that was coming to around $160 here in the specific place that I had looked at. But to be fair, like in that place, it's not uncommon to get things that have sort of a markup on them. But yeah, $160 for that thing was a little too much. I definitely didn't want to. I mean, I got that specific thing as a gift, so I was grateful for that, because that kind of gave me something to be able to explore with. But like buying it again, I wouldn't buy it from that place. I would definitely want to buy it online, just so I can get it cheaper, and just so there isn't a higher markup on it. I actually wanted to try one of the knockoffs, like they have orange, they have banana. I wanted to see how those would work out, but then I'm not too sure about the tooling surrounding them. So I would much rather go with something like I would much rather go with just the Raspberry Pi than the one of the knockoffs. the specific reason, by the way, for not going with the knockoffs is because they were slightly cheaper, but they were not significantly cheaper. If they were significantly cheaper and then within my price range, then I would have been willing to give it a try. But I mean, to be fair, like 8 GB, 16 GB, I'm getting a whole computer, so I can't really complain too much. But still, I wanna try and get it cheaper. I want to buy it directly the from the Raspberry Pi people. I'm used to markups too. I live far away from most distribution centers. I had the same thought. My first SBC, I wanted to be legit with lots of documentation. Yeah, yeah. Because I looked into orange and banana. I don't remember which one I decided to go with. Maybe it was orange. I decided to go with because they had like a whole website set up, and it seemed like they have tooling. I don't know how mature the tooling is. The software that you would be able to run on this, I don't know how mature it is, how how bug free it is, and I'm willing to give this kind of stuff a try. I'm willing to give knockoffs a try if I can get them for cheap. Then I would be willing to give it a try because I mean, if I end up being able to run a Linux based distribution on it, let's say I'm able to run. I actually wait. There's a different OS. I just remembered that as well. There's a different OS that you would be running on this. You wouldn't be running the usual. In this case, I think I would be running Ubuntu, which I already run on my machine. So I'm kind of like comfortable with that already. But like in that case, it's a whole different distribution that you would be running as well. You wouldn't be running the typical Raspberry Pi Ubuntu thing. But yeah, I wish I could get I wish I could get these kinds of like full system on a board for much cheaper. Though to be fair, they are pretty cheap for the price that we are getting them. They are pretty cheap. They're just not cheap enough for me because I don't have a lot of money. So I kind of need to, you know, be cheap with it, be economical with it. At some point, though, later, I would definitely like to get a bunch of Raspberry Pis and set up a little home lab kind of thing because there's a bunch of like very interesting stuff that you can do, especially once you start using stuff like Proxmox and Linux containers and stuff like that. I think I could try doing that on one of my systems right now. That thought just occurred to me. One of my systems that I have, it's a very old system that I could probably run Proxmox on and then use it. But like this is like super old. This is a very old system. Um, yeah, yeah. I don't know. I mean, I'll look into that at some point later. That being said, I need to end the stream here. Unfortunately, I'm not able to run longer. Um, but yeah, I'm glad that I was at least able to stream, even if I had to do this whole thing where I, had to add in an extra gain filter and speak low and still somehow I'm able to be audible. That's great. And we still had these technical issues and stuff. Uh, it is what it is. But yeah, Zanar, thanks for stopping by. Thanks for chatting. I appreciate it. I'm probably not going to be rating anyone today. I'm just going to end the stream. I'll also try to stitch those. I don't know if it was like 5, 10, 15 minutes of the previous stream. I'm going to try and stitch that into this, and so then I can upload the entire thing together. But yeah, that's going to be it for today's stream. Um, I'm going to stream again tomorrow, and tomorrow I'm going to uh, hopefully start the stream early, and then we can do a good like hour and a half, 2 hours, and we're probably going to get back to doing Rust studies. I still have to like dive into that turbo fish stuff because it's a pretty interesting concept, and I'm really intrigued by that. Like, really intrigued by it. But yeah, for now I'm gonna play with my electronics and continue doing research on the electronics as well. Once again, Zenar, thank you for stopping by and chatting. Anyone else who might have been lurking in the chat, thanks for hanging out. Um, yeah, that's it. I hope you guys have a nice day, and I'll see you all next time. Peace.